Water waves. We know that most of the Earth's surface is covered with oceans. So let us try to understand a little more about these oceans. The waters of the Earth's oceans are mostly in the liquid state. What happens when you take a half-full bottle of water and shake it up? Do you see the water in the bottle moving rapidly? You know that particles in a liquid can move about, mixing up completely with one another. The waters of the Earth's oceans is also always moving, and it gets all mixed up too. There are many things that move about the Earth's water like wind, waves, tides, swimmers, boats, etc. Of all these, waves and tides actually make the water move about a lot. Ocean waves. Everything from earthquakes to shipwrecks creates waves. However, the most common cause is wind. As the wind passes over the weather's surface, friction makes it ripple. The strength of the wind, the distance at which the wind blows, and the length of the gust decide how big the ripples will become. These ripples are called waves. In deep water, a wave is a forward motion of energy, not water. In fact, the water does not even move forward with a wave. So what moves ahead in a wave? Energy, not water. If we followed a single drop of water during a passing wave, we would see it move in a vertical circle, returning to a point near its original position at the wave's end. Does that seem too hard to understand? Look at this ball and the bottle in the wave. Observe how they are moving. Did you see how the ball just moved in a circle right there? But the wave moved on ahead. That's how the energy moves ahead, but the water doesn't. We see the waves moving the water like that only near the surface. As you go deeper in the water, the waves have no effect. In deep waters, the waves are quite calm, but in shallow water, the tips of the waves become more peaked. The speed of the waves increases and the wave breaks as it hits the shores. Surging breakers. On beaches where the slope of the land is very steep, the wave does not actually break. Instead, the wave rolls onto the steep beach. A surging breaker looks like this. Plunging breakers. Plunging breakers happen on beaches where the slope is moderately steep. This kind of wave normally curls over, forming a tunnel until the wave breaks. Expert surfers love this type of wave. Spilling breakers. Spilling breakers occur on beaches with gentle slopes. These waves break far from the shore and the surf gently rolls over the front of the wave. Spilling breaker looks like this. Think and discuss. What is a wave? Where do waves have an effect on the water? Near the surface or deep down? In a wave, does the water actually keep moving forward? Tsunamis. Sometimes waves reach heights of 40 meters, that is 120 feet or more. These waves are known as tsunamis. Look how tall the waves of the tsunami of 2004 in the Indian Ocean were. Tsunamis are the most dramatic and destructive of waves. They cause huge damage to coastal areas. That is why tsunamis are also known as killer waves. Underwater disturbances such as volcanoes, earthquakes, and landslides are the cause of these monster waves. The larger the disturbance, the larger the tsunami will be. A big tsunami formed in the Indian Ocean on 26 December 2004. This wave caused a lot of damage to the coastal areas of Andhra Pradesh, Kerala, Puducherry, and Andaman and Nicobar. The wave travelled at a speed of 800 kilometers per hour. More than 1 lakh people were killed and lakhs of houses were destroyed. This wave was formed due to an earthquake measuring 9.0 on the Richter scale. Now you know how intense the earthquake was. But what caused this earthquake? You already know how earthquakes form when tectonic plates move. Here, the Indian plate went under the Burma plate. This caused sudden movement of the ocean floor, causing a powerful earthquake. The epicenter of this earthquake was close to the island of Sumatra. Scientists cannot predict earthquakes, but there is a way to know that a tsunami is approaching. Before a tsunami hits any coast, the water from the coastal region moves back rapidly. This is an important sign to know that a tsunami is approaching. There are warning systems in coastal areas of many countries. The warning stations keep monitoring the coastal regions. If there are signs of an approaching tsunami, people living near that coast are given a warning well in advance. The people along with their valuables can move to a safe place. Thus, a lot of lives are saved. The damage to property is also less. However, when in 2004 the tsunami struck the Indian coast, there were no warning systems built. So no warning could be given for the approaching tsunami, and as a result, the damage was huge. Think and discuss. What is a tsunami? What causes it? Why are tsunami waves called killer waves? Why are early warning systems installed across oceans?